blockchain architecture using light-up pop tubes. We have to remove the battery tabs and create a GitHub repo to initialize our blockchain project. Each of these tubes represents a component of a blockchain. Let's say this one's the virtual machine that powers smart contracts, this is the token, the address and private keys, governance, NFTs, and anything else you want to put into a blockchain. You can build these components any way you like, with any features you desire, but to construct a classic blockchain, you have to build it in a monolithic fashion. That means that everything is connected to each other in one continuous block of code. And I do this by adding the tubes or blockchain components end to end, resulting in a ring. This is a monolithic blockchain. Now if I want to upgrade the network, like Ethereum 2.0's upgrade from proof of work to proof of stake, I need to perform a hard fork. It looks like this component isn't working right, and there's lots of disputes over it, so we can't use it. Let's try a different component. Alright, this one is the improved proof of stake module here. How do I perform this hard fork? I'll need to break the system so I can extract the old and insert the new. Unfortunately, doing so can cause some unintended consequences, like interrupting other services. Now, after some troubleshooting and debugging, the monolithic blockchain is finally upgraded and all is well. But is there a better way to construct the blockchain so that it's infinitely upgradable without hard forks? Well, let's begin by decomposing the blockchain back into its basic components. What about using a modular design? Modularity treats each blockchain component as an individual piece that serves a specific purpose. They can be joined without actually connecting the pieces together, unlike our earlier monolithic example. All of the components, such as smart contracts, governance, or the consensus algorithm, are all fully independent but still able to communicate with each other. I construct this by looping each new component into every previous one, but always connecting it back to itself. And just like that, I constructed the Koinos blockchain using a modular design. Upgrading is now far easier. Let me demonstrate. Let's say we have this module and we want to add it to the blockchain. I can install it without disturbing the blockchain itself by weaving it in. I never disturb the existing pieces and there is no network downtime. Now, what if we wanted to upgrade an old module? I can simply target that specific module using Koinos' built-in governance system and extract the old and install the new, all without shutting down and hard forking. And just like that, I can create a blockchain that is infinitely upgradable without hard forks. Now let's do something fun with these toys. With blockchains like Koinos, you can be as creative as you like, because smart contracts are always free. dApp developers won't have to struggle to convert users to blockchain or hope they know how to acquire tokens first. Because on Koinos, you can use the blockchain without ever holding tokens thanks to Mono, the system that allows tokenless and fee-less transactions. If you want to learn more about Koinos, please check out my other videos. I hope you enjoyed this video and thank you for watching. And be sure to like and subscribe. Thank you.